Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you can find information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible to the extent allowed by law, a donation to support our actuarial students, please go to smarturl.it/help ISU actuary. Here's the problem for today for exam P on probability. An investment account earns an annual interest rate R that follows a uniform distribution on the interval from 0.04 to 0.08. The value of 1,000 initial investment in this account after 1 year is given by V equal to 10,000 e to the R. So as you can see, that R is really continuously compounded interest rate or force of interest. Determine the cumulative distribution function f of v of that random variable v defined by the formula v equals 10,000 times e to the r for values of v that satisfy that f of v is between 0 and 1, which is the natural condition for the values of cumulative distribution function, which also can be equal to 0 or 1, but this is in between those two values that we're asking for the formula, and we have a choice of 5 formulas to work with. Well, so this is a classical transformation of random variable, but not in the form of finding the probability density function, but a cumulative distribution function, and it can be solved directly from the definition of cumulative distribution function. So we are given that R is uniform on the interval 0.04 to 0.08, and V is equal to 10,000 e to the times e to the R, and then the cumulative distribution function of V is given by f of V equals probability that V is less than or equal to V, which is the probability that 10,000 e to the R is less than or equal to V, which is the probability that e to the R is less than or equal to V over 10,000, which is the same as the probability that R is less than or equal to the natural logarithm of V over 10,000. And we actually know the probability density function of R, because R is uniform on the interval from 0.04 to 0.08, and that density is simply 1 over 0.08 minus 0.04. So this value of this probability is simply the integral from 0.04, the beginning of the interval where the density is positive, to the point where we want to find the probability for, so ln of V over 10,000 of the density, and of course the density is a constant. It's 0.04. And you could actually just guess this answer from knowing how the cumulative distribution function of uniform distribution works. So this has got to be equal to the natural logarithm of V over 10,000 minus 0.04 divided by 0.08 minus 0.04. Or this is simply in comparison of the length of the interval from 0.04 to the natural logarithm of V over 10,000 to the length of the interval from 0.04 to 0.08. Now, of course, 1 over 0.08 minus 0.04, that's 1 over 0.04, that's 25. So we can just write this as 25 times ln of V over 10,000 minus 0.04, and that's the form of answer that we have in answer E, so it's answer E. Please remember this is copyrighted material. The problem itself belongs to a society of actuaries. The solution is mine. Good luck in your studies and good luck on the test.